This is section 5.7, and we're going to talk about interest and money because that has to do, exponential things come into play in compound interest and continuous interest. So, first thing to do is look at the formulas. Now, we're not going to do anything with simple interest, but we are going to look at compound interest. The formula is A equals P parentheses 1 plus R over N parentheses raised to the NT. Let's talk about what those pieces mean. A is the accumulated or future amount. It's how much money you end up with after your money earns its interest. P is the principal or present value. That's how much money you put in the bank to start with. R is your interest rate. And if you're doing them by hand, you will have to put that in decimal form. N is the number of compounding periods. That's how many times are they going to run this formula on your money in 1 year. And then the T is the time in years. So that's important to note. If you have a problem that says that you left your money in for 18 months, you do not use 18 for the time because it has to be in years. So that'll be 1.5. Then we have a formula called continuous interest, and that is when it's compounding all the time. You still have principal, rate, time, and the amount that you end up with is your A, and you use the number E. So let's look here. Find the amount that results from each investment. You have $100, you're investing at 4% compounded quarterly after 2 years. So I like to write down what I'm talking about. P is for $100. That's how much I'm putting in. R is 4% or 0.04. You're compounding quarterly, so that means N will be 4. 4 times a year you're going to do this. And time is 2. So I wrote the formula again. Now I'm going to plug in the pieces. A equals 100 times 1 plus 0.04 over 4, all of that raised to the 4 times 2. You can do that in the calculator, or there is a calculator app that will let you do that. We'll look at that in a minute. Let's see. Let's go here. Let's look at a couple of others. So 600 invested at 5% compounded daily after 3 years. So P would be 600. R would be 5% or 0.05. N, how many days in a year? We're going to count 365. That would be your N, and T is 3 years. Still plugging in, you would get 697.09. Continuously, when you see that word, you know you're going to use this formula, and you're putting $40 in, 7% interest, 3 years. So it's 40 times E raised to 0.07 times 3. Find the principal now to get each amount. So that means you're solving for P. You already have A. To get 600 after 2 years, 6% compounded quarterly. So A is 600, R is 6%, N is 4, T is 2. So I put the 600 here equals P times this. So I'm solving for this. What you can do is figure out all of this piece on your calculator, then divide it into 600, and you get the 532. Okay. You might have a problem where you're comparing, but we'll do one of those in our homework. And then rate, finding the rate of interest, that is a long question if you're doing it by hand. If you are doing it on the app that I'm going to show you, it's much quicker. So you could do this, but this method is going to be quicker. We also are going to talk about effective rate of interest, and that means you're compounding n times per year, but you have an annual interest rate R, and so the formula looks the same, and you're going to take away 1 over here. You don't have your P out here. So your effective rate of interest, you have 1 plus R over N raised to the N minus 1. And so why would you need to do that? Well, if you this is showing you an example. And banks are very close, but if they were figuring, you wanted to find out where the best deal was, you could use that to figure out their effective rate of interest. And you can see with American Express, we got this. First Internet Bank, we got this. And Discover, we had this. So you can see that this guy's going to give you the best interest. It's the highest rate. So we'll have a couple of problems on that. All right, let's go look at the calculator app first. So in your calculator, you would hit, and I've got this in here in your lecture notes, you want to hit your apps button, and I will, let me get my calculator. So I've got my calculator up too as well. So here is the apps button right next to math. So that's a little bit older calculator. And so right there, and when you hit that, just like I'm showing you here, you wonder what that is. That should not be, I don't know what that deal is. We should hit finance first, but let's hit enter on finance. I didn't show that screen. So before you get to this, you have to choose the finance. Let me go backwards on that and hit apps and see the first one is finance, hit enter, and then we're at this screen that you have. All right. And so when we choose TVM solver, we get this. So let me minimize that. So I've put what everything stands for here. N is the total compounding periods. That means if you're compounding quarterly for 5 years, that's 4 times a year for 5 years. So your big N would be 20. So it's total compounding periods. I%, you do not have to put that in decimal. You just put the number for the interest rate. PV is the principal. That's how much money you're putting in the bank. You ignore the payment. We're not doing anything with payment. FV is the future value. That's usually what you're going to be solving for. PY and CY is the number of compounding periods in 1 year. Okay. And so when you're ready to solve, like this is put information in from this example, $400, 11% quarterly. So quarterly 4 times a year for 3 years. So my N was 12, my 11 is my percent of interest rate, and then my put in $400. This was 4 because it was quarterly. Then I get back to future value. That's where I want to solve. Put your cursor on FV and click on alpha and enter, which is solve, alpha solve. When you do, you'll get a value here and you ignore the negative sign and your answer would be 553.91. So these notes are in your lecture notes. You can follow that to do this. Let's go look at the problem set. All right, the total amount borrowed, whether by an individual from a bank in the form of a loan or by a bank from an individual in the form of a savings account, is called the principal. So that's how much money you either put in the bank or you're getting. And then here we just did this problem with the app. This is doing it by hand, but remember we just did that right over here. 553.91. So you can see that that's a great way to do it. All right, find the amount that results from the given one. This is continuously. You cannot do the app when it says continuously, so we have to use this. So $30 invested 10% compounded continuously, period of 3 years. We have 30 times e to the 0.10 times 3. When you put it in your calculator, let's just go here, second quit. When you want to do 30 and you need the E, remember that second and LN, and you got the E. And what are we putting in? 0.10 times 3. Since it's all up there, you can just do that at one thing. And you get 40.49495. So we're going to round it to money. It'll be 40.50. Okay. All right. Now I've put screens for most of these others. You're looking for the principal. So you can still use the app. It's really nice. You want 600. We're going to put 600. We're going to put a negative in because we know that it spits out a negative there. So let's put that in. It's 4 years compounded monthly. So that's 12 times every year for 4 years. So your big N will be 48. 11% interest. We're going to be solving on this, so just leave that at a 0. Payments is 0. FV is negative 600. PY is 12, and that'll automatically make CY 12. So we got all of that in. We go to the cursor, we put our cursor on PV, and we solve there, alpha and the inner key, and we get, that's covering up the 3. We get 387.20. Now it needs to make sense. If you got a number bigger than 600, well, that wouldn't make sense that you'd put something bigger than 600 and only end up with 600. So 387.20 makes sense. Number 5, again, you're solving for the present value and you put the same kinds of things in. So we can do that. Number 6, find the effective rate of interest for 20% compounded quarterly. So we're going to do this. We're going to write the formula out, and then I'm going to plug in. So 1 plus 0.20 divided by 4, because we're quarterly, raised to the number of, so I have 4 there as well, and then a minus 1. So my suggestion for you to do this is to start right in here at this piece and do it in little pieces. 0.20 divided by 4, you hit enter. And then you're going to add 1 to that right here, enter. Then you're going to raise it to the 4th power, enter, and then you're going to subtract 1. So let me show you doing that real time. Okay, it's clear. All right, so 0.20 divided by 4, enter, and then plus 1, enter, raised to the 4th, enter, minus 1, enter. And we've got that 0.215. And so that's the effective rate of interest, but we want it in percent. So we're going to move the decimal 2 places. So, and it says 3, so 21.551. You'll do the same thing for this one, and you get 22.712. So same formula. Which of the 2 rates would yield the larger one? 12% compounded monthly or 12.5% compounded annually? So you're going to, you can do the same thing on your app. The 2 things that will change will be your big N, your percent, and your PY/CY. So if this is annually, PY and CY are 1, and that's 1 year is what you're doing, 1 times 1. So big N is 1, and this is 12.5. You're putting in $100, you solve, and you get 112.50. Over here, you're doing monthly. So this becomes 12 and 12. That becomes 12. The percentage rate is 12. And you ultimately get 112.68. So this one is going to be better. You'll get more money on this one. This one you're solving for the interest rate, so you can still use your app. So you're putting in $100. You are solving on this interest rate. You are trying to double your investment in 20. So if we, what I decided was it doesn't matter what numbers you use, you're just talking about doubling. So I said, okay, I'm going to say what interest rate is going to let me put in 100 and end up with 200. So put your 200 in as negative on the future, put your 100 here, put your 29, your compounding annually. So that's 1 time a year for 29 years. So your big N is 29. Here is 1 and 1. When you solve on interest rate, you get 2.418. You're going to round it to 2 places, so you'll have 2.42%. Okay. So you're solving for that. And because it just said double, let's see, you're going to double an investment. You could have used 1,000 and 500. You could have used 10 and 5, whatever it is. You want this to double to get here. And so that should be pretty easy. All right, number 10. How many years will it take for an initial investment of 30,000 to grow to 45,000? Assume a rate of interest of 17% compounded continuously. So you are solving for time. This is where your exponential equation comes into play. So we have A equals PE to the RT. We know we have 45,000 we want to get to, and we start with 30,000. E raised to 0.17, and we're looking for time. All right. So remember, when we solve these, you isolate. So the 30,000 gets divided over here. That reduces to 3/2. Then you're going to take 3/2 equals e to the 0.17t. Take the natural log of both sides. And remember, our rule says ln of e to anything leaves the anything. So now I have 0.17t equals ln of 3/2. T is equal to this. And if you do it over here on the, if you look at the calculator screen, you can see that you get 2.385, and you're going to round that up, and it'll be 2.39 years. Okay. What will a $140,000 house cost 10 years from now if the price appreciation over that period averages 5% compounded annually? All right, so what are we solving for? We're solving for future value. Future value. So it's 10 years and you're compounding annually. So total compounding is 1 time a year times 10 years. So that's a 10. 5% goes there. 140,000 is what it costs now. And PY and CY are 1 because it's annually. So we're going to solve on FV, and we get 228,045.25. So 10 years from now, with appreciation, a house that cost 140,000 will cost 228,000. So that's good to know. All right, last question, number 12. Jim places 10,000 in a bank account that pays 10.9% compounded continuously. After 2 years, will he have enough money to buy a car that costs $12,434? If another bank will pay him 11% compounded quarterly, is that a better deal? So the first one we have to do by hand. So we take 10,000 times E raised to the 0.109 times 2. And we see that that is the amount of money he would have. All right. Then we can do the other one in the app. And we're doing it 2 years, and we are doing quarterly. So 4 times a year times 2. Big N is 8. 11% is the interest rate for this one. Present value is 10,000. PYCY are quarterly, so that's a 4. And you solve on FV, that's 12,423, and here's 12,435. So this one isn't enough money to buy the $12,430 car. This one is. So Jim's bank is better than the other bank, just barely. All right. So I think that will get you used to using the app. And again, the calculator app page is in your lecture notes. So be sure that you use that and you'll get through 5.7.